Land and soil are the livelihood of all of us, but the resource land is threatened by climate change, reduction of animal and plant species, and by inefficient farming.
In the way we managed our landscapes in the last decades, we destroyed various ecosystem functions and consequently put our life support system at risk. Our task thus is to produce agricultural commodities without compromising ecosystem functioning.
Ralf Seppelt is head of one of the biggest global research projects on sustainable land management at the Helmholtz Center for Environmental Research in Leipzig. The program consolidates research results from 12 different regions in the world. One of the key questions of the project is whether and how enough food could be produced in the future. According to recent forecasts, the Earth will need to support 10 billion people by the end of the century.
This balancing act between sustainable land use and sufficient food production is possible. Measured in calories, for instance, after all, we produce about double of the food that the world actually needs.
12 research teams worldwide investigated practical solutions to the greatest challenges. How can we use land in a sustainable way? How could we promote biodiversity? And what effects does climate change have on local systems? One example is the Kalunda steppe in southwest Siberia. In the 60s, the region was said to be the breadbasket of the Soviet Union, but drought, depleted soil and wind erosion shrank the crops more and more on the 420,000 square kilometre plain. German and Russian scientists developed a sustainable land use management concept with the Kalunda project. For 4 years they cultivated and evaluated test fields at 3 locations on the steppe. With less use of soil and specific crop rotation, the team soon achieved a significantly higher harvest while at the same time consuming fewer resources. Another example, rice farming at Ifugao in the Philippines. The insect known as the brown plant hopper causes large crop losses in the rice fields of the Philippines and Vietnam. In the project Legato, scientists found that insecticides are counterproductive because the poison rarely affects the insect but instead wipes out its natural enemies, for example, spiders. Rice farming that supports the natural enemies of the pest, however, can result in much higher yields. An important aspect of all the projects was the participation of local stakeholders, and the scientists worked to foster a consciousness of the problem among the local population. Here it achieved exemplary results. Vietnamese television broadcasts instructional videos and sketches on fighting the pest in the fields. For the practical use of farmers worldwide, a book was published featuring examples of best practice in the area of sustainable land management. This information is also available on an app. The scientists in the 12 projects generate a huge amount of data. At the Helmholtz Center for Environmental Research in Leipzig, this data is gathered and assessed. In the GeoPortal, findings are illustrated for the public. From a global perspective, the project brought to light many new findings, but also scientifically underlined some worrying trends.
Our findings point out that we could not increase the rates of crop production very much more. The analysis shows that quite a few important goods like maize, rice, wheat, fish, meat or milk already passed peak rate years of the highest production in the recent years. The usual response is to extend agricultural area to farm more and more land, but this comes with tremendous loss of biodiversity and is in fact no option.
Humankind must not, contrary to the accepted opinion, define new areas for farming. The growing world population could be fed without problems up to the year 2050 if we decide together to change diets and reduce meat consumption.
Besides the fact that we need to reduce harvest losses and need to reduce waste, the global outcome of food could be raised with multiple crops by about 40%. Moreover, crop losses could be minimized with ecological engineering, which we define as to manage ecosystems in a way that the productivity of farming keeps stable and sustainability rises.
This global research project on sustainable land management lasted for 7 years.
Finally, the core result of all research findings is that to protect ecosystem functions and to sustain biodiversity, it is not enough to avoid the loss of natural land and to promote conservation areas. No, it is much smarter and more effective to use ecosystem services even better. We could sustain a crucial amount of biodiversity and can mitigate climate change cleverly instead of opting for technical solutions, such as, for example, expensive insecticides or energy-demanding fertilizers.